All right, we are on section 1.3. These sections are pretty long, so it's taken us a while to get to 1.3, but that's okay. Our section is called Exponents. A lot of people struggle with this, okay? You've learned this definitely in Algebra 1. They taught it in Algebra 1. I'm sure they taught it in Algebra 2. And that brings us to where we are now. So I'm going to teach this basically as if you've never seen it before. Girls, Zira? All right. So I'm going to teach this as if you've never seen it before. Some of you guys probably can do these problems just like that. No big deal. But I'm not going to make any assumptions. I've never taught you guys in math before. I'm not really sure of your background. So I'm going to teach this as if you have not seen exponents before. But you all have. Who's worked with exponents before? Yeah. A lot of you didn't raise your hand, but I know you did. All right. So what if we had something like this? What does that mean? Somebody tell me how you say that. 2 squared. Or you could say, 2 squared is the best way to say it, but what's another way you could say it? 2 to the power of 2, or you could say 2 to the second power. Okay, what does that mean? That means you're going to take this right here. So it means you take this big number right here, and you take it to the second power. What does that mean? It just means you multiply that big number, which we call the base, by the way. That's called the base. And then the little number on top, that's called the exponent. All right, so you take the base, you multiply it by itself how many times? Well, as many times as your exponent tells you to multiply it. So it would be just 2 times 2, which is 4. What if it was 2 to the third power? Or what's another quick, easy way we say that? 2 what? Cubed. So 2 cubed. What does that mean? It means we take the base and we multiply it by itself how many times? 3 times, okay? That how many times is or whatever number your exponent is, that's how many times you multiply that base by itself, right? So 2 times 2 times 2, what is that? That's 8, all right? What if we had negative numbers? It is? No, it's 8. 2 times 2 is 4. 4 times 2. 4 times 2 is 8. You're not adding, you're multiplying. You're multiplying. 2 times 2 is 4. 4 times 2. Yeah, you are tripping. 4 times 2. You're not adding. What's 4 times 2? What's 4 times 2? You are tripping. All right. It's times. It's multiply. It's not add. It's not 2 plus 2 is 4 plus 2 is 6. It's not plus. It's times. 2 times 2 is 4. 4 times 2. What's double 4? 8. All right. So it's 8. So it's multiply. These dots mean to multiply. All right. Let's do another one. What if we had this? All right, he's got it now. All right. All right, we need to move on. Here we go. So this is negative 3 cubed. All right, which means you're cubing. Remember what we do when we cube stuff? We multiply by itself 3 times. So we're going to multiply this negative 3 by itself 3 times. Now, this is very, very important. This is where it gets a little bit tricky. Right here is pretty basic. Right here is where it gets a little bit tricky. So it's in parentheses, and that's a huge deal right there. It's very, very important. Actually, to tell you the truth, with this problem, it doesn't matter if it's in parentheses. But when it's an even exponent, it absolutely matters. But let's use the whole process here. So what are we cubing? What are we multiplying by itself 3 times? We're taking negative 3. We're multiplying it by itself 3 times. Everybody see that? All right. So what's negative 3 times negative 3? It's positive 9, right? And what's positive 9 times another negative 3? It's a negative 27, okay? Now, if you wrote it like this, you're going to get the same number, but you're going to get the same answer for a different reason. Watch very carefully. What are you cubing here? Are you?
Yes. No, you're cubing 3.
You're only cubing a 3. You're only cubing the 3, but whatever you get when you cube the 3, you just take the negative of it. Everybody see that? Now, I'm telling you, you're going to get the same answer, but you get it for 2 different reasons. So if you do this with an even number exponent, which we'll do in a second, you'll see that your answer will change. All right. When it's an odd exponent, you're going to get a negative answer. You always get a negative answer. But when you have an even exponent, you'll get positive. And we'll do a couple of these. So what does this mean? It just means negative. And then what is this? 3 times 3 times 3. We already did it up there. Let's do it in your head. What's 3 times 3 times 3? 27. It's still the same answer, but you get it 2 different ways. Everybody see that? On this one, you just keep the negative out in front, and then you just cube whatever is underneath of that exponent. All right? But you still get negative 27 either way you do it. But what if you had this? What if you had, let's do an easier number, negative 2. What if I did negative 2 to the 4th power? What does that mean? That means negative 2, how many times? 4 times. Okay? So this is what this means right here. It's important that you understand that. So you've got look at all the negatives. I got 1, 2, 3, 4. What's that going to come out to? Is it going to come out to positive or is it going to come out to negative? It's going to come out positive because negative times negative is positive, and this negative times negative is positive. Positive times positive is positive. What's 2 times 2 times 2 times 2? 16. And it's a positive 16. Everybody see that? Now, what if you had this? That's right. Okay, this is different. This is different than this, and you're going to get a different answer. You're like, well, Mr. Hamrick, you have the same answer there. Why wouldn't you just get the same answer here? Because of your exponent. If your exponent is if it's an even number exponent, you're going to get a positive answer. If it's an odd number exponent, like we had up here, you'll get a negative answer. So what does this mean, though, right here? It just means you put a negative out in front, and then you just do this right there. What is 2 to the 4th? We already did that. It's a 4, but your answer is what? It's negative 4 because this negative is just hanging out front. Okay, it means take 2 to the 4th power. I put 4. Why did I put 4? Somebody stop me. Is nobody going to tell me?
I thought I was.
Don't be tripping. All right, 2 to the 4th is 16. Sorry about that. So 2 to the 4th is 16, but then you just throw that negative out in front because it's negative 16. Do you see the difference between the two? This is in parentheses. This means you're taking the entire thing that's in parentheses and taking it to the 4th power. This right here, you're only taking the 2 to the 4th power, but you're chucking a negative out in front because you got a negative out in front of this. That's one of the big issues that I see when we deal with negative numbers with exponents. Everybody with me? Not everybody's with me. I need to call your name out. I didn't call it out. All right. So let's do this. I'm not going to do that one thing they do. I'm just going to go right to an example. So those are just to get us started. Alex, question. Yeah.
Power 3 and it's cubed.
Right. Well.
Fourth dimensional shape.
Yeah, don't think about shapes. Okay, don't think about shapes.
So let's do the power 4. Would it be type of cube?
No. So how do we say this? Actually, let's do this. Don't put equals. How do we say this? I'll put a quotation mark. We say x what? Squared. All right. How do we say x to the 3rd power? X cubed. All right. Now, if you go above 3, x to the what? And that's what we say. That's what we say. Okay, you could say, what somebody say earlier, x to the power of 4. You could say that. I hardly ever say that. I usually just say x to the what? 4th power. Or sometimes I just forget the power. I just say x to the 4th. All right, that's fine. I'm good with that. There's no like special fancy word that you use. But you use squared and cubed so much, that's why they give them their own fancy words. After that, I mean, sure, you use them, but not quite as much as you use squared and cubed. So that's what we would say, just x to the 4th power. So what if I had something like this? How would I say that? X to the 17th, okay, or just x to the 17th power, or x to the power of 17, all right? But I would probably just say it's x to the 17th power. Everybody got that? All right, so let's do some examples. I'm going to write these examples down, and I want you to come up with an answer, then we'll go back and look to see how you did, all right? So there's 6 of them. So figure out what this is. By the way, it says write each number without exponents. So simplify. A lot of times it might just say simplify. So this is not simplified. We can figure out what that number is. You do it. All right? Everybody write it down. I'm going to write down 6 problems. You write them down, and you come up with an answer. And let's see how you did. All right, there you go. Give a minute or two. Probably shouldn't take any longer than a minute. That's why it looks like there's a lot of problems that I'm assigning tonight. But they're so quick. Shouldn't have any problems. 41 problems tonight. That's a little unusual. I don't usually give you that many. But they're quick, they're easy. You should be able to do it just like that. All right, so it shouldn't take you any longer. Might even take you less time than a normal homework assignment that I give you, even though there's a lot of problems. Give you another 30 seconds. So nice to have my screen back in normal. It was just so far back, the projector wouldn't get that small when it was that far back. So I had Alberto come in and moved everything, so it worked out pretty nice. Bless you.
Yo.
Everybody ready? Gave you more than 30 seconds. So here we go. 2 to the 5th. What does that mean? It means 2 times 2 times 2. How many times? 5 times. What is that? It's positive 32. What about this one? Negative or positive? I heard some positive. I heard some negatives. Let's fight it out. What is it going to be? Why is it negative? Right, because 5's an odd number. Very good. Okay, so it's going to be negative what? 32. Okay? What about this one? This one's an even number, so it's got to be positive, right? Yeah, it's 256. It's a number you probably don't normally do in your head, 4 to the 4th, but it's 256. It's a positive or negative? It's an even number. It's still negative, because remember, you're not taking the negative to the fourth power. You're only taking the 4 to the fourth power. That negative just slides on in front, and then it's 4 to the fourth, which is 256. That's why it's negative 256. Yeah.
So when we're doing that test, are you have to calculate it? No. This is not mental math for me.
Big number. You have to do it on your big number.
Look, 4, 4, 4, 4. Okay. Well, you can do that in your head. You can do that in your head, right? What's that? Okay. And what's this? That's 16. So you should be able to do this off to the side. You learn how to do this in 3rd, 4th grade, right? 6 times 6 is 36. 6 times 1 is 6 plus 3 is 9, right? Put a 0, or some people put X. You don't know how to do. Oh my word. Well, I'm teaching you now. So you put a 0 right there to hold the place. 1 times 6 is 6. 1 times 1 is 1. Add them up. That's a 6. That's a 15. That's a 2. 256.
I haven't done multiplication.
So on the test, should we calculate?
Well, it's not kindergarten. They didn't. I think 3rd grade. If I remember back, I think I learned how to do that in 3rd or 4th grade, maybe something like that. Probably. All right. I don't know. That's my answer. So here we go. Let's take a look at this one. Now you know 4 to the 4th is 256. What's the answer to this? It's positive 256, because you are taking the negative to the 4th power on this problem. So if I have 4 negatives is what? Is positive. So it's 256. Lost you on this one? Fractions, right?
Oh, wait.
All right. So what are you doing? What's going on inside this parentheses? Everything's being taken to what power? To the 3rd power. So what do you do with 1/2? Yeah, take it to the 3rd power, or you could do this, right? Because that is 1/2 to the 3rd power. Everybody should be able to do that. Everybody should be able to do this. Okay, so you multiply straight across. I got people not paying attention. I need everybody's attention up here. Multiply straight across. That's a 1. Straight across here is an 8. All right, so 1/2 to the 3rd power, or 1/2 cubed, is what? 1/8. And now you just take the A, because what this parentheses means is you just take everything in there to the 3rd power. Okay? Do them individually. So 1/2 to the 3rd is 1/8. A to the 3rd is just what? A to the 3rd, or A cubed. And that's your answer right there. It's as easy as that. So now that you can do that, you should be able to do this one. Do this in your head. What's negative 1/5? Now remember, that whole negative it's in the parentheses as well, right? So you have to square the negative. So what's the sign going to be? Is it going to be positive or negative? It's going to be positive. 1/5 square is 1/25, and then b squared. And there it is. The letters? Decoration? They represent numbers. You just don't know what the number is. Listen, the letters are pretty important, because later on, please don't make me hush you every single time I got to say something. You should just be quiet automatically. Don't say you're sorry. Just don't say anything. How hard is it to understand that? I don't get that. Let's try again. When you have variables, right now, it may not look like the variables are doing anything. Okay, we're not learning engineering right now. We're just learning the very, very basics. We're just learning basic skills, because later on, whether it's in this class or another class, it could be in physics, in chemistry, it could be when you go to college and you maybe take an engineering class, something like that. These variables are going to really be important. Okay, they represent numbers. We have formulas that we use. We got all kinds of formulas with all kinds of variables that you would plug numbers into. You're going to have to do some algebra. You're going to have to do some things with the variables to be able to come up with an answer to a formula. All right, it's very, very important in math that you know how to take a variable to an exponent. You know how to multiply variables. You know how to do things with variables because life is variables. Okay, when you have an engineering, you're gonna have to come out with some kind of formula in order for your bridge to stand up and not fall down. All right, and if you want to make the same kind of bridge here, and then you want to make maybe a smaller version of it somewhere else, the variables change, but the formulas still stay the same. There's all kinds of reasons that I'm just not going to get into now. All kinds of reasons you need to know how to work with variables. Let's keep going. That is a formula. That's correct. All right, now this is what we're really getting into. That was really basic stuff. You probably already knew most of that, and you probably know this stuff right here that we're about to do. But again, I'm teaching this as if you've never seen it before. What if you had this? What if you had x to the fifth and I asked you to multiply it by x to the third? So what does x to the fifth really mean? It means what? X times x, how many times? 5 times. So let's just write that out. We're not going to do this every time. It'd be silly. But this is going to establish our formula, our little rule that we're going to use, our property. So x to the fifth, what is that? It's 5 x's, right? 1, 2, 3, 4, 5. And you're multiplying it by x cubed. So we're multiplying it by what? How many x's? 3 x's. So I can just put them right next to each other, right? They're all the same variable, right? So how many x's now do I have altogether? I have 8 of them, don't I? 1, 2, 3, 4, 5, 6, 7, 8. I got 8 of them. So how could I rewrite this? I could write this, what? X to the 8th. Now, instead of doing that, that would be horrible. Because what if I had, like, x to the 74th times x to the 37th? Okay, if the only way that you could do this is by writing out all those x's, that would be ridiculous, wouldn't it? Agreed? All right. But you know what's going on. There's 5 x's right here and 3 x's right here. What'd you just do to them? You just added how many x's you have, correct? Is this an addition problem, though? It's not an addition problem. It's still a multiplication problem. But what are we going to do with the exponents? You're going to add the exponents together. This is still a multiplication problem. But how do you find what your exponents are when you're multiplying? Now, this only works if you have the same base. All right? If I had x to the fifth and y to the third, there's nothing I could do with that. All right, I just leave it like that. All right, but when you have the same base and you have exponents, you're multiplying, you add the exponents. Everybody see that? So now that makes this one a little bit easier to do. So what would this one be? Can you do the addition in your head? That'd be an 11. That's 11, right? That's a 10, carry the 1, so that's 111. So that'd be x to the 111th power. It's kind of silly, but that's how you would do it. Okay, so we need a rule for this, and they call this the product rule for exponents. All right, so I'll write it all out. It's called the product rule. Why product? What does that word indicate? Multiplication. And what are you doing to these two things right there? You're multiplying them together. So here's what the basic rule says. Basic rule says x to the m times x to the n. What do you think that's going to be? They're same base. You got different variables. You got different exponents. X to the what? To the mn.
M plus.
Is this x to the 5 times 3? Okay. To the x plus n. That's different than xn. Or I'm sorry, mn. Mn means you're multiplying them together. So what would this be? M what? Plus n. And there's your rule right there. Put it in a box, put some bells and whistles on it, do something, all right, to make sure you remember that rule. All right, everybody got that? Not everybody. Guys are starting to, I got 1, 2, 3. Their heads down. All right, here we go. Here's an example. This is example 2. It's kind of stuff you'll see on the homework, on the quizzes, on the test. All right, here we go. X to the 11th times x to the 5th. Give me an answer. I'm just going to write all the examples down. You come up with the answer. I'll give you a chance to do them. Don't make me do all the work. So this is a to the 5th. This is a to the 4th. This is a cubed. Write that down, get an answer. Here's another one. A squared, b cubed, a cubed, b squared. All right? Yeah. All right, last one. Negative 8x to the 4th times 1/4 x cubed. All right, there you go. Should be able to do these in your head super quick. This one's not that much harder. It's all multiplication. Even if you don't have any dots. If there's no dots there, what does that automatically mean? No, it is multiplication. Okay? If you don't have a dot there, if these things are next to each other, it means you multiply them together. All right? For instance, like xy. If I just have xy, what's going on with those two numbers? They're being multiplied. Exactly. All right? You don't have to have a dot there. These don't have dots. There we go. Yo, Chauncey, wake up. Come on. Mom and Dad told me to text them, right, or email them if I had any trouble. Yeah. Yeah, because look at C.
Is that an 8?
This one? Yeah, that's an 8. My 8s are weird for me to write. I don't know why. That looks better. I got to take my time. With them, but
So it's negative 8x.
negative 8x to the 4th, 1/4 x cubed, parentheses. All right, what'd you get on part A?
I got
To the 16th? Yep, very good. Why is it not 55? I thought it was multiplication.
But that is not the product rule for exponents.
That's right, it's not the product rule for exponents. The product rule for exponents says when you multiply with exponents and you have the same base, that's a key, then you add the exponents. Okay, so you're adding the exponents. Everybody got that? Yeah. Good.
So when we do that, let's do x to like plus x.
Well, you got to add them. I mean, you could do a middle step if you wanted to. If you wanted to go like this, is that what you're saying?
No. I mean, like, you see the dot, this is like a plus.
Oh, you couldn't add them together because they're not like terms. If this was a plus in between, x to the 11th plus x to the 5th, you couldn't do it. All right, because they're not like terms. But you can do this. Multiplication, you can. What about this? A to the what?
A to the 12.
Yeah, because you're just adding the exponents. 5 and 4 is 9 and 3 is 12. Okay? What about this one? This one's a little different. Remember what you can do. You can only, when you multiply with exponents, you can only do that when you have the same base.
It's a to the 4th times b to the 5th.
Sure? Right.
Okay, you know how to do it.
Well, you got to say what you mean. So this is going to be a to the what? 5th. Right? So you can only multiply the ones with the same base together. And then this b and this b, you can multiply them together. So b cubed times b squared is b, again, to the 5th. That's how you write it. You can't just put like one big thing to the 5th. Well, technically, you could put ab in parentheses to the 5th, but we'll talk about that another time. Let's do this. What's the hardest part about this? It's probably the fraction, right? All right. But it's not so hard, is it? It's negative 8 over 1 times what? Remember, this is multiplication. Now, the 8 doesn't have an exponent. The 1/4 doesn't have an exponent. But it is multiplication. So let's just multiply them together. So it's negative 1/8 times what? 1/4. Remember how to do these without a calculator?
Nope.
4 goes into 8 how many times? Twice. And it goes into that once. So what is it? It's negative 2 because you got that negative out in front. Okay? So it's a negative 2. What about the x's? I get an x to the 4th times x cubed. What's that going to be?
X to the 7th.
To the 7th, right, because you add the exponents. Okay? Don't multiply the exponents, add the exponents together. And that's your answer right there. Is this coming back to you?
Yes.
Let's do one more. We got time for one more. one more rule. Let's keep it blue. I like that color combination. What if you had this? What if you had x to the 5th, but it was in parentheses, and then you had it cubed on the outside? Okay? Let's see why. Because what does this mean? It means x to the 5th cubed. So I'm going to write x to the 5th how many times? 5 times? 3 times. Because I'm cubing it. Okay, I'm taking x to the 5th, and I multiply by itself 3 times because I'm cubing it. Correct? Now we could go back to that product rule that we just learned, right? The product rule for exponents. So what does the product rule say? If I have the same base, I keep the base the same, and what do I do with the exponents? Just add them up. 5 plus 5 is 10 plus 5 is 15. So it's x to the 15th. Or I could have done this. Now watch, Sam, I'm up here. So look at this. Do you see the 5 and the 3? Do you see the 15?
Yes.
So relationship between 5, 3, and 15?
Yes.
What is it? Just multiply it together. Okay, so this is called the power rule for exponents. I'm just going to write power rule. I won't write exponents. It's called the power rule. And basically, it's this. If I have a base to a power, if I take a power to another power, see what I'm doing? I'm taking the m power to another power. If you have a situation like this, then what do you do with the exponents?
Multiply.
You multiply them together. So how would I write this? Megan, now you can say it. X to the what? M times n. That's right. So that's your power rule for exponents. Okay? Let's we got half a minute left. Let's squeeze it in. Here we go. Watch this. What if we had this? What's the answer to that? No, it's a 2 and it's a 3. 3 to the 6th power. That's right. Okay? Now, 3 times 3 times 3 is 6 times. I wouldn't expect you to know that one, but that's 729. Okay? Let's do another one. What if I had x? This will be the last one. The bell rings. Just hang on for a sec. And this is to the 6th. So x squared, x cubed, to the 6th power.
X to the 30th.
Why is that?
Because 5 plus 2 plus 3.
Where'd you get the 5? Inside of here. That's right. So again, order of operations. You do what's in the parentheses first, correct? So what's in the parentheses? X to the what? 5th. So don't think that you're going to just multiply all those numbers together. Okay? You do what's in the parentheses first. That's x to the 5th. And then that's to the what? To the 6th. Everybody see that? Now you can apply the rule, and it's x to the 30th. All right, you got the homework sheet in front of you. Get the homework done. That's due tomorrow.
Walk, Megan. I'll talk to him.
It's page 36.
No, I'm gonna guess it.
Before that.
27 to 67. And you're doing all of them. All of them. This is section 1.
So logic.
All right, hold on.